Greetings and Assalamualaikum. My name is Mirza Nur Haziqah binti Nazri. I am under supervision of Dr. Nur Azizi bin Osman. I am going to present on my research topic entitled Transmission of Vibration Humans Hand to Arm. Human is exposed to different mechanical vibrations in normal daily lives, either during traveling through vehicles or handling the machinery tools. Many businesses were relatively with vibrating tools such as mechanical repair, workshops, heavy fabrication and building construction. The vibration is transmitted through hand-arm system, which is from palm and fingers to the hand, arm and shoulder, which is known as hand-arm vibration. According to the Control of Vibration at Work Regulations 2005, the values they need to be aware are known as exposure action value EAV and exposure limit value ELV. The exposure value defines as EEG, which is 8-hour reference period of vibration, reflecting the normal time of workday. EAV is the daily amount of vibration exposure an employee needs to take action to control it when exceeding 2.5 meter per second square EEG. ELV is the maximum amount of vibration an employee may be exposed in a day, which is 5 meter per second square EEG. Excessive exposure to HEV in a single day will result in hand-arm vibration syndrome, vibration-induced white finger, and Raynaud's disease. The signs are including pain, numbness, tingling in fingers, loss of strength and grip, and pale or blue fingers. HAVL is also known as an occupational disease and has affected many workers. They might not feel the pain in the short time, but this issue might threaten them in the future. However, there are a few ways to manage this problem and turn it into less risky, like by reducing exposure to HAV and by improving productivity and quality of end equipment. Thus, by applying damper when using vibrating subject can reduce vibration effectively and practically, as the kinetic energy absorbed and convert vibration energy to other forms such heat. This study is significant as the risk of getting health problems also can be reduced. The objectives of this research are to identify the hand-arm vibration magnitude on hand drill machine, to reduce the exposure value for hand-arm vibration on hand drill machine, and to evaluate and determine damper with optimal performance in reducing vibration magnitude. The scope of this research focuses on hand-arm vibration on a hand drill when it is in idling state to avoid resonance. This is because the vibration of a machine is best during idle instead of when drilling on any workpiece. The experiments are carried out in 3 minutes period time and repeated for 7 times. There are 5 types of dampers used in this study to reduce the vibration magnitude of hand drill. Next, methodology. This is the workflow for this research. Firstly, the specimen of experiment needs to be identified. In this case, it is hand drill. Before starting the experiment, calibration of apparatus is needed to ensure readings from the instruments used are consistent with other measurements, and also to determine the accuracy and reliability of the instrument. After that, the experiment is set up properly to ensure it runs smoothly. Next, experiment is conducted without damper first to get the reading of vibration magnitude of hand drill. Then, the rest of data is collected by using dampers to reduce the vibration. Once the experiment done, the results need to be evaluated whether there is a difference in the vibration reading or not. If the vibration reading decreases when damper is applied, then the experiment is succeed since hand-arm vibration on specimen is reduced. However, if there is no difference in vibration magnitude, the experiment needs to be repeated from collecting data. After all the experiments have been carried out, then the best damper use can be evaluated. In my research, I am using Kando Powerhouse Professional Impact Drill. The corded drill is chosen instead of cordeless drill because the power produced is tend to give more vibration. The specimen needs to be originally higher in vibration amplitude before damper is applied to compare the difference in the readings at the end of the experiment. The magnitude vibration reading of subject is taken using vibration meter SV106 and triaxial accelerometer SV105. The figure shows the schematic diagram and the actual diagram of experimental setup. The vibration meter is connected to accelerometer using connecting wire, and the accelerometer is attached to the hands palm. The dampers used in this research are in form of gloves with different kinds of materials and properties. There are clothes glove, wool glove, closed-grip glove, polyester glove coated with polyurethane, and the combination of closed-grip glove and polyester glove coated with polyurethane. For HAV, the sum of triaxial acceleration experienced by a worker in three axes, which are x, y, and z axes, need to be calculated for the vibration magnitude measurement. The orthogonal axis of HAV measurement is shown as in the figure. The risk of HAV based on the vibration total value, which expressed in meter per second squared, by summing up three values for three axes x, y, and z using equation as shown, where AHV is the vibration magnitude and AHW represents the value of each component of axis. Next, results and discussions. This is the result of vibration magnitude of hand drill without damper. As mentioned before, there are three axes need to be considered. By ignoring the yellow line first, the x-axis, which is the blue line, has high vibration magnitude reading compared to y and z axis. It shows that the vibration occurred more towards x-axis. Reading of vibration total value, which is the yellow line, in each experiment is exceeding EAV. The average of vibration magnitude reading of hand drill without any damping gives 3.26 meter per second squared, even though the average vibration total value has not exceeding the standardized ELV. However, it has exceeding the EAV, which indicate a state that approaching to exposure limit. Therefore, there is a need to curb this problem so the user is not inflicted by HAVS in the future. After the vibration magnitude of hand drill has been obtained, the reduction on HAV is taken place by attaching damper to the vibrating tool. The results of the study show that the reduction of vibration magnitude occurs when damper is applied, as the excessive energy dissipated from the system. The comparison of the magnitude of vibration acceleration among the parameters has been done in the graph shown. The average total magnitude with the combination of PESPU and closed-grip glove is 1.25 meter per second squared, which is 61.66% lower than the reading without damper, and it shows the highest reduction percentage compared to other materials. PESPU glove comes second with 60.12% reduction rate. The highest average vibration magnitude reading with damper is closed-work glove with 1.8 meter per second squared, which is only 44.79% reduction from when without damper is applied. As conclusion, from the research, the hand-arm vibration magnitude value on hand drill without the presence of damper was identified using vibration meter and accelerometer and gives value of 3.26 meter per second squared. The exposure values for hand-arm vibration on hand drill was successfully reduced by applying damper on the tool, and each damper shows reduction value in the experiment. The damper with optimum performance in reducing vibration magnitude value was evaluated, and combination of PSPU and closed-grip glove was determined as the most effective damper among others, with reduction percentage of 61.66%. That's all from me. I end up my presentation with thank you.